right, so wind. As you can see in this image from the beginning of our book, well, you can see the little eddies of the clouds that are going as they pass through this island, right? Very similar to a visualization of water eddies. So we're going to talk about a lot of stuff about wind in a nutshell. This chapter starts off talking about the monsoon and the monsoon effect. I wish we had a world map in here. Most classes have a big world map. Well, rather than going over this, actually, some pictures are good. So remember when we talked about continentality and how land masses warm up more quickly than water, right? So when you have a northern summer, the sun's coming down here, hitting the land, right? The land's heating up more rapidly than the water. So this low pressure, what that means is this air is rising, right? Because the sun's hitting it, it's hot, so this air is rising. When air is rising, well, it will suck in air from other places because you can't have a vacuum. And so what happens is, well, when that air is brought over, and it's moist air from the ocean, well, when it goes over land masses, you can get some rain, right? Especially if it's forced up in elevation, because like I said before, the air is kind of like a giant sponge. So as it is forced over these mountains, every bit of water is drained out seasonally. And so that's the monsoon and the monsoon effect. Now when people talk about the monsoon, they'll often think the monsoon is like a specific storm that is only in Asia. But we talk about it here because it's the most intense here, but this monsoon effect happens wherever there's land and water. So technically, over the US, we get a mild monsoon effect that's not as strong, but that's in a nutshell the monsoon effect. In with this, when it is, well, winter in the northern hemisphere, you have the opposite situation, where all the air is coming from land. Now, air from land tends to be much drier, right? So that's one of the reasons why water resources in places like South Asia, they need to really monitor how much rain is happening, how is it stored and collected, and then also, well, the dry season. You could have a dry season that's more than half the year where you don't have a drop of water, and you need to have planned out what you're going to do, right? So like I said, that's the monsoon effect, why we talk about it in this area compared to other areas. Well, let's actually backtrack a little bit. Well, actually, so since this is Bangladesh, a country in South Asia right by India. Let's see. People know the population of Minnesota?
Like 8 million or so.
I think it's like 5.5 million. 5.5 million. Bangladesh is about half the size of Minnesota. Let me see, make sure my facts are right. I want to just, it's always the risk of bringing the internet into school. All right. All right, so Bangladesh, 170 million, right? 170 million. Population of Minnesota, 5.7 million, right? Bangladesh is about half the size of Minnesota. So if you could picture how much you gotta plan ahead resources to feed that many people, right? Just giving you a little bit of an idea of what places have to deal with. And what's been happening recently, in general, there's been a rise of temperatures. Let me go back. A rise in temperatures, and what that means is a couple things. That means that this air here has even more moisture in it. And that means that these storms are even worse than they have always been, and they've always been pretty bad. I don't know if people saw a bunch of news stories about Pakistan and floods last year, but there are multiple times during the year that literally half the country was flooded out and people were walking in knee-deep water. Half the country, right? And so when we talk about things like climate change and whatnot, these are the things people are worried about. Well, had predicted would happen for a long time, and now they're happening, right? All right. Air pressure and wind. Well, we talked about this in the last chapter about how wind is moving around because of the sun, right? The sun is basically heating up some places and it's making the wind move around. Well, barometer. This is how we measure air pressure, and this is actually how we can usually gauge where the winds are going. Where the winds are going. I don't know if you've seen an old barometer. You have some mercury. The air pressure on the mercury pushes it up into a tube, and then you measure the change of air pressure in millibars, right? Changing air pressure. Let me go to, in general, as you go up in elevation, there's less air pressure, in general, right? Remember, air pressure, it's just the air that's above you. So if there's less, if you're going up a mountain, there's less air above you, in general, less air pressure, right? Has anyone ever gone in a high elevation and gotten like altitude sickness? Some people, yeah. Tends to happen to people who are kind of longer, so taller and thinner. It's more difficult for your body to equalize, that type of thing. If you check for ancient populations around the world that tend to live at high altitudes, they tend to not have that body form. Because, well, as I discovered when I tried to climb high elevations, you get sick, you get nauseous, you get headaches, and you feel the need to go back down as quickly as you can. Extremes in air pressure. So just a little visual about air pressure, what that means for winds, right? If you have low pressure above you, right, you got your barometer and it's like low pressure, well that means that we have some air that's coming in, right? If we have low pressure, it's going up. If it's high pressure, the opposite. We have winds that are going to be going away. Let me not talk about these types of air pressure. Wind speed and direction. Well, we've got 3 different things we're going to all take in turn. In a nutshell, this point here, air flows from areas of high pressure to areas of low pressure. That may seem like a no-brainer, right? When your tire is punctured, right? Outside is under a lot less pressure than your air tire. You know, when you're filling up your tires of your cars, you can see what the pressure is, right? Well, that pressure is going to be higher than our atmospheric pressure. So if there's a hole, rather than the air just kind of sitting there, it goes out. That's the same thing that's true for our atmosphere. The air pressure is always attempting to equalize. Always attempting to equalize, right? So if you got some places that have high pressure and low pressure, often these are entire weather systems, so you could have a cold front and a warm front here, but you'll have one moving to the other. As you can see, the wind direction going in one direction there. Isobars, they're how we measure this pressure. And so again, looking at a map and using the same things that we were just looking at, just a bit differently. We have high pressure and low pressure. When these isobars are near each other, well, that as you can see, it's going quickly. It's going quickly, right? And so this is part of our we're starting to get into the weather prediction kind of part of the class that we'll eventually get. Just another visual. And go. All right. Coriolis effect, which is a very kind of difficult thing to wrap your head around. In a nutshell, in a very simple nutshell, Coriolis effect in the northern hemisphere makes objects veer to the right. Objects like when we're predicting hurricane paths. If you see them on the news and it's like, well, why isn't this just going straight? Why is it turning this way? Well, that's the Coriolis effect. Not to be confused with, people think that the way the water goes down the drain of your tub depends on whether you're in the northern and southern hemisphere. That does not, because you could just swish it and it will switch directions. There's no magic about what direction it goes. It's random. This is large things that are on the Earth's surface, and nothing small like a drain. But again, this is also, the Coriolis effect adds to things like hurricanes and adds to things like tornadoes, adding that twisting mechanism in. So this is also a reason why, why planes, you know, if you've ever been in a plane and they show you your route on the plane in a little map, and it looks like it's not going straight, well, that's because they got to take into effect the Coriolis effect to know where they're going. Pressure gradient Coriolis effect. So as you can see, well, the wind is going in a direction. Winds in general in the northern hemisphere will always be turning a bit to the right. This has to do with the Earth being, it's not a flat surface. If it was a flat surface, these things would just go straight. But we're a curved surface, right? So what looks like turning to the right on the map, on the Earth's surface, that is rounded, it makes more sense. Again, a reminder, just northern hemisphere, things are turning to the right. Whatever direction they're going, they'll be pulled to the right, right? Whatever direction they're going, and the opposite in the south. Well, we're talking about winds already quite a bit. Winds can be dangerously high, of course, but well, winds are also affected by the Coriolis effect, right? Coriolis effect has a strong pull, so the winds won't necessarily go in a straight direction that they seem like they would be going. Also, in general, when we're seeing names of winds, winds are named from the direction which they blow, as it says, from which they blow. So if you have a wind that are called the easterlies, and someone says, well, where are those from? You'd be able to answer pretty simply. It's one of the good things about naming winds. They tend to just be, just say what it is. All right. The only one that is slightly confusing, well, windward, right? If we're talking about winds, windward, we can understand what that means, because that's where the wind is coming on a landmass or island. Leeward is one of those terms that is less easy for people to kind of remember, but just remember it's the opposite of windward. Don't need to talk about how we measure the wind. Got devices that measures the wind. Let's just move on to cyclones and anticyclones. This is another topic that will sometimes be confusing to students, because if you're watching, like, let's say you're watching international news and they're talking about the weather, they will sometimes, depending on where they're talking about, they will talk about a hurricane or a typhoon or a cyclone, right? And you'll think to yourself, what's the difference between those things? The names. The names are the only difference between those things. Does people in different places refer to the same thing with different names? But also, cyclone itself refers to not just a storm in winds, but can refer to larger systems. I think I got an image. So in the middle of North America, we have a normal cyclone that is just kind of always happening, and it kind of moves around place to place. And it's not a cyclone like a hurricane, like this is a hurricane here, very classic hurricane shape. Our cyclone is obviously over land, and its movements and what come about from the, well, not from the power of the ocean and those winds. Our cyclone tends to not have as much moisture as a hurricane, and it's spread over a larger area of space. But again, we would call that a cyclone, because it is still a churning mass of air. Let's go back. And I would just say, well, anticyclone, again, it's what it sounds like. So let me show you why North America always has this cyclone going on, right? we tend to, in general, have kind of warmer air masses down here, colder air masses up here. But this gets twisted up, right? Coriolis effect, winds from other places, it gets twisted. And then very often what happens is you have low pressure points that will kind of break off, high pressure points that will break off. This is one of the reasons why we get some of these really chilly days sometimes. And so actually this whole next week is supposed to be really cold. I think like 10 below zero for a few days. Now if you put these all together, this is basically a process that is just continuously happening in the US. So when you see weather maps, you'll see these things like this emerging here and there just from that constant churning process. Other visualizations of the same thing. A little bit more about hurricanes. As you can see the twisting mechanism there. You could also see the relative amounts of high pressure, low pressure. Measuring this is part of the way we measure how strong a hurricane is going to be. All right, so we're going to talk about 4 global pressure systems. And we already have a little bit. I don't know if you remember this little diagram from earlier. We talked about this process, right, and the creation of these desert belts around the world. Well, the system is a bit more complicated than it seemed, but let me see if I can explain how these different things work. The main driver we have is the sun, right, and in general around the equator there's a bit more sun, so in general you have air rising there, right? Air rises and it has to come back at some point, so it does eventually come down, but it is very dry, right, when it comes down from this direction. Now let's go to the opposite, polar, right? Opposite, it's getting the least amount of sun, it's the coldest, and so the air, rather than rising, is constantly falling, right? And well, what that does is, as you can see, the air tends to circulate about to here, and then it just kind of creates this cycle. Just like this creates this cycle. And then what you have here, you have a cycle that is just made because of these cycles. This cycle is made because you have air coming this way, so you can't have air going the opposite way, right? You have air flowing in the same general direction, but that makes the air masses over where we are, including random polar fronts that will just kind of happen every now and then, depending on the time of year. So the center one, like I said, we talked about this before, intertropical convergence zone, and I feel like we actually covered that one quite a bit. Subtropical high, let's back up, that's just the next one over, right? Subpolar low. This is the visual from the book showing these same things. I put in my other visuals because I think that those are actually better than the book's visual in this case. But in general, again, you have air mass rising, falling here. Polar, you have the air is always coming down, and then it's rising and coming down. And this image doesn't really show the stuff that happens over where we are that much. That's why I brought in those other images. Another map showing the same thing and showing in general these high and low pressure systems. And again, just remember, you got sun coming in, air is rising, circulates. It's always cold here, so the air is always going down. And those things are what drive the whole system. And you can see from this map that it's, well, there's seasonal change of this system, and these systems are generalities, right? So for example, you can see that the actual atmospheric pressure here is a variety of things. That's because these all move a bit seasonally, right? So this is January, right? July. You could see this high pressure system, but you could see that it is not just a full line through, right? There's kinds of ups and downs here and there, kind of depending on where you are next to land masses. of talk about more specific wind patterns. I would say the trade winds in general, well, their name kind of denotes one of the main reasons that people know of them is people know of them for traveling, right? These are the first big trade routes that people were mapping specific wind patterns, which ways you can go and whatnot. So for example, when the Pacific Islands were settled by people, it took thousands of years. People did it by swimming and by boats. And the winds in general over the Pacific Islands are all going the wrong way. They're all pushing people back to Asia. And so when people were trying to, before modern boats and things, they're trying to paddle and explore, they'd always be pushed back in the wrong direction. So that settlement took a long time, right? Many other areas of the world, the wind was on their side and were settled much more rapidly. Prevailing global wind patterns. The doldrums I also talked about quite a bit as well. That's just the area around the equator where the air is rising and you have kind of constant rain. But the Coriolis effect is weakest at the equator and strongest at the poles. So things like hurricanes, well, if the poles were warm, you would have huge, massive hurricanes because of such a strong Coriolis effect in the spinning. But hurricanes they need heat to get going. So ideally, if a hurricane could pick where it was going to be, it would say, well, around the equator, but there's no Coriolis effect. There's no spinning, so it just dissipates. That's why we have the doldrums. Coarse latitudes, again, that's where the air is coming down and it's dry, right? Everywhere around the world. There's a section in the book about empty quarter of Saudi Arabia. There's a number of different areas that are in these latitudes that are very, very dry, where the land, well, it's not that productive. Let's put it that way. I don't know if people have traveled to some of the desert regions of the world. I've been to Egypt, and when I went, it was interesting because people just kind of refer to all the land that's not in the Nile Valley as kind of the dead land. Well, in my experience in Egypt, a lot of it is being filled up with garbage because it's a large area to put garbage and out of sight, out of mind for people. Westerlies, polar easterlies, again, winds that come from the direction of their names. Let's talk about some upper level winds. Again, we are talking about flying in planes and the Coriolis effect, but we have a lot of jet streams that allow pockets for air travel to be able to kind of, go much more quickly, save money on fuel, things like that. Because similar to water currents, there's all kinds of little smaller currents that go here and there. In general, when the seasons are going by, we often will get, similar to what we saw before, where you have sections of the Arctic polar wind will come on through, and it will cause usually pretty short-term cold problems, especially here in Minnesota. Polar jet stream. But of course, pilots have to decide if these actually make sense for where they're going to go, right? If you wanted to go from here to here and you wanted to take the polar jet stream, well, you have to see if that is really going to be worth it, taking you that much out of your way, or if a direct path would make more sense, even though it was outside of a jet stream. Usually that type of a difference, they would not want to follow the jet stream for that much space. Rossby waves, they're important because very often what they will cause to happen in weather is you'll have that polar vortex of air go down even further than it just kind of normally does sometimes, and for a longer period of time, right? And so when that happens to us sometimes here, That's what's going on. Right? Term they use, polar outbreak. But again, I feel like we experience this pretty regularly in our winters. It's of note because these types of weather phenomena happen to an area larger than the normal, right? We're used to kind of this normal area kind of dipping to be polar, but not like this much area. It happens, it's just less frequent is I guess what I would say. Seasonal shifts in global pressure. Well, obviously, as the Earth tilts, since the power is driven by the sun, the area that, gets the most heat from the sun changes depending on the time of year, right? And so what that means is that whole system that I was showing you of waves and whatnot, as the Earth goes through the seasons, they'll kind of go through different continents, right? That's why they have different weather. Let's see. So in January, right? Well, what do we see going on here? We see, high pressure system, right? Opposite of what's happening during the summer. So we see air kind of coming this way, the opposite direction. What else can I say about this map that would be of interest? I guess that's the main stuff that is important to know. I would also point out, we have a whole section on oceans and whatnot, but these winds strongly affects currents in the ocean and vice versa. And these ocean currents in general, you can see in both of these examples, north of the equator, so things are going in general to the right when they're happening. Also in general, winds and water that are coming from the south tend to be warmer, from the north tend to be cooler, right? So again, like I said, we have a whole other chapter on currents, but I thought I would throw this in here real quick, just kind of show you how a number of things are affected. The Coriolis effect, for example, you can see in general, you have a pattern going this way, and in general, you have a pattern going this way, right? Every now and then you get this opposite current that happens. Sailors and navigators kind of pay attention to that. But that changes seasonally. And a lot of these winds change seasonally. But hopefully you can see mostly the trend of, in the north, things going to the right, in the south, things going to the left. I'm not going to talk about a whole bunch of stuff about air pressure. I'm not going to talk about wind scale systems either. I will talk about mountain breezes and valley breezes. As always, I think visuals are a bit better. So during the day, right, you have the sun coming on. Actually, two images are better. During the day and the night, right, you'll have opposite wind patterns in places like mountains. Because during the day you have the sun rising up, heating up the land temperature, and it will pull in warm air as that air is rising, and then at night we have the opposite effect, so you'll have winds going the opposite direction. Visualization of the same thing from the book. Sea breeze, land breeze, very similar thing, where this can change depending on the time of day. But again, in general, right, sun going over water and land, the land always heats up more rapidly. And then, the land also cools off more rapidly, right? Heats up more rapidly and cools off more rapidly. And so if there's a body of water by your area of land, that is what's having an effect of your wind directions. Again, visualization from the book of the same thing. Let's talk about some specific winds. I talked before about rain shadows and about how very often mountains, especially if they're very large, you could have wind that's being forced to go over them. When it's forced to go over them, goes up, right? That sponge of the atmosphere is squeezed out. When it's come down the other side, not only does it have no more water in it, but as it's coming down, that's pressure and that's heat. And so you'll have very often specific winds that could heat up quite rapidly. And you could have areas, like I said before, that people have tried to kind of suburbanize, and they'll want to make it a suburban to kind of Midwestern look, but that's not really appropriate for that climate. So that's one of the reasons why you'll have huge fires if there's just like a spark. I think there's a image somewhere. And then, you know, you can see the huge amount of smoke coming from just a couple fires. But, you know, you'll see these on the news every now and then, right? When it'll be entire neighborhoods will have been wiped out. Increasingly, it's starting to happen in states that people did not think that this would happen that much in, like Colorado. People assumed, you know, these things would happen in Nevada, California, Arizona, because these are all places that are quite warm, and we kind of understand their desert landscapes. You have a question?
Did we have forest fires in Minnesota last year or 2 years ago as well?
Oh yeah, we absolutely did. But they didn't have the winds quite like this. But that is a terrible combination when there is dry winds. I would say what we're getting more of is we're getting more of all this smoke from these fires. That's kind of a unique thing. Just the past couple of years, it used to not be the norm that every summer you would have these bad weather days where there's a bunch of smoke coming from the West Coast. Now that seems like a normal thing. I was in Europe last summer, and as I was traveling, trains would be canceled and whatnot because there were these giant fires that were happening. In general, a lot of places like Europe, Europe tends to have a lot of moisture. They tend to not have as many kind of wildfires or whatnot. But as the climate in Europe has warmed a bit and has dried a bit, there's just a combination of that causes more fires, right? Katabatic winds. These are winds that you don't need to worry about too much because they're coming off of glaciers. Got an image here. They're extremely cold, but they tend to be very dry. So you actually have areas of like Antarctica that are not covered with ice. Not a lot of these areas. Some of the areas here. But the wind that's coming down off of the glacier doesn't have any moisture in it, but you'll have these huge intense winds. Let's see, this talks about the monsoon again. I feel like I explained the monsoon relatively well. A diagram from the book of how much rain can sometimes happen during the monsoon. I don't know if people have been watching about the rains in California these days. California was in a drought, a somewhat catastrophic drought that had been going on for years. But due to a change of wind patterns and whatnot, they have spent like a good month under what people describe as a atmospheric river. People describe it that way just because, well, I think I got a visual somewhere here. Don't I? I'm talking about El Nino. Let me go forward a little bit and then reverse. So when you have weather events like El Nino or La Nina, which we're having this year, it can make it so that normal wind flow patterns are just off a bit. And so other places that were used to having a river of rain, so for example, Washington State tends to have a lot of rain. But if the atmosphere is, well, slightly contorted so that all goes somewhere else, well, it was all dumped on California. All right, let me backtrack a little bit. So I should talk about what El Nino is. El Nino refers to a warming, this is South America here, a warming off the coast of South America. And this is a phenomenon that used to happen like every dozen years or so. But it seems to be happening with more frequency these days. And what that means is, like I said, that just means a lot of different normal weather things are just slightly off of where they would have otherwise been. Create some different weather patterns here and there. The map in our textbook doesn't go into a lot of detail about specifically how we're affected. You can see we're near where it's a bit warmer. That's often the case. And it's one of those things where it's like, it doesn't really affect our weather a huge amount compared to other places. Our rain isn't cut off, or our rain doesn't all of a sudden happen in huge amounts due to El Nino. You may hear the term La Nina as well. That's just the opposite of when things basically go back to normal weather patterns. Farming the wind. The end of this chapter talks about wind farms and whatnot. And wind farms are not a new thing by any means. People have used that energy for a long time. What I could say about wind energy is it's increasing through time. There's lots of places around the world that just do not have access to fossil fuels, right? Tropical islands, for example. Or actually, the last time I went to Costa Rica, they're heavily investing in wind power because otherwise they got to import everything, right? Got to pay a lot of money for these resources. So a lot of places are switching to wind. A lot of countries that don't actually get a ton of wind are still investing in it because they want to utilize that as a clean resource. Geography of the wind. I think there's a map. So if you look at this map, this is one of the reasons why if you hear about a lot of wind farms in Texas especially, you can see that we have a lot of good consistent wind speeds kind of in the center of the US in general. And again, that's because that's where we're always getting these twisting winds. We're getting these kind of constant wind patterns. You may also notice that you have really high wind speeds over the Great Lakes. Makes a lot of sense because the things that slow down winds tend to not be on lakes, right? Trees, mountains, not a lot of lakes that have mountains on them, because that doesn't make sense, right? But that's a possibility for future wind power. Wind farms in the US and Canada. You can see there's a cluster here in that area that I was talking about. This cluster here, let me go back. Does that cluster make a lot of sense? Yeah, it is higher wind speeds there than the area around it, I guess. Let's see, when people talk about wind power, they'll often talk about how it's not reliable, right? Because sometimes the wind slows down. It's like, well, sometimes it does. What else do people talk about? Environmental impacts. There's a lot of people who, in general, think wind power is just fine. They just don't want to have any of it themselves. They don't want to see it when they're looking out their window. Often called NIMBY. You've heard that term. Not in my backyard. People also talk about the amount of birds that are killed by wind turbines. No, people don't really talk about bats. I don't know why. People don't care. But people care about birds. Well, global annual bird kill estimates. Wind turbines, 100 to 400,000. I tell you what, if you're worried about birds, don't let your cats out. Don't let your cats outside. That's what's killing all the birds. That and obviously birds just flying into windows. Just happens a lot. But, you know, you're gonna stop making windows? But you should stop letting your cats out. Alright, what I'm gonna do now, I'm gonna have you guys, give you plenty of time to work on a little writing assignment. Did everyone get 3 different articles? Where's the pile of extra articles? Are they at the end? Piles of extra articles, okay. Who does not have all 3? Alright. Alright, so as I'm handing these out, these are all papers about El Nino and its effect on Minnesota weather, specifically. Alright? So what I want you to do have all 3, or do you only have 1?
I have all three.
Anyone else need, oh, we do. Yeah. Alright, so what I'm gonna do is I'm gonna have you, as always, break off into groups. And I'm gonna have you all use these articles to answer a question that you will, as a group, turn into me. Anybody else need some? Oh, we got one. As a group, using these articles, I want you to tell me what the effect of El Nino is on Minnesota weather. I also want you to evaluate these papers. And in what you're going to hand in to me, I want you to write which one is a B paper, which one is a C paper, which one is a D paper, and why. And I will have you break off into groups between, I'll get self-select, but between 3 to 6 people per group. 3 to 6 people per group. Maybe I'll type up these instructions.
Yeah, but we're also explaining what, how El Nino affected Minnesota.
Okay, why don't we look for how it's affected Minnesota first, and then we'll have to.
Then we'll
And then
evaluate.
as we're going, I can already see like,
And we
in
write
this
on,
one,
I think we just explain.
well, we just explained.
Well, I'll just read it
And then I
and we'll
think
see what we
we're gonna have to
found
start
out.
with one of these, but like I
We'll do
can,
yours then.
yeah.
I'm gonna take a guess, like, the ones, especially this one, like, it already has like 2 references, you can say short in there, so this is probably a D paper, like off the bat.
I feel like this one that
Never know,
says
you have to read
both, this one that starts with both already gives me an.
Did I cover that? Must be still.
Yeah, it's just like the, now let's talk about like, this just seems like very informal, like the.
Okay, let's.
Okay, yeah,
we'll go
because
first.
it is research and it's more like
Yeah.
factual than, like, let's just say example instead of like a
But
personal.
that one
Yeah.
has now let's talk, but this one has folks now let's talk. So I feel like that's a little even.
I think I already know which one it is.
Anyway,
But you have to read how it sounds.
okay.
But Ari will take out there.
So our question that we're supposed to do is like, what is the effect
About
of
what?
El Nino on Minnesota? So let's try to figure that out. Okay.
Oh, actually.
Yeah.
Yeah, we gotta read the whole thing.
And also, it's good to have a header. It's good to like have a header at the beginning of it.
I mean, yeah, but folks, let's talk about it, you know, like, that's not a good header. Like, I honestly think this one might be the paper. It just starts with an introduction,
Here's the
like,
thing
it's
though,
like the
so
El
I
Nino.
don't
What?
with doing all that. Well, we know it's somewhat.
They're all not great because they're only one page. I'm just gonna say.
Yeah.
But we can pretend that they'll give them.
Ever felt like it's example like
Okay, yeah, just reading through this one, I
Well, I
swear
think
it
our
repeated
paper- I
itself
think
like
we have to do
6
longer than one
times.
page in our-
So like
Okay,
a
there's-
1,000 words, like 2 or 3 pages.
That's not bad.
Okay, anyway.
Okay, we can-
And it only has two references.
Let's start, well,
I
first
think
let's just
that's
answer the
also
question.
assigned, this one's got 20, so it's 3.
El Nino has affected Minnesota weather.
Yeah, this one already gets better.
Oh, yeah.
Yeah, I started reading this one.
Yeah, because we're doing yeah. No, I just, I can help you point out. Okay. Warming up.
Sources are probably out of that one.
And we're central time, right?
Installation ones
Or
should be-
we are,
We are central.
we are central time, correct.
Former air mass is moving in.
I mean, this isn't. Jared said.
Increased rainfall.
Like, literally, just changes, so it's all, and we get a lovely long winter, which I do not like. Just snow.
This one, I slice it open.
What are you saying, Mr. Deep Paper?
I think there's A, B, and C.
I know, it's B, C, D. I think, yeah, I think this one is probably the deep paper. Like, well integrated sources.
That's also probably not making it too easy. Exactly, that's why, that's.
This one's
I
way
think
better.
this one's similar to just the introduction.
Yeah, I was gonna say like the introduction, and then it's like, you already know, like, oh, this, like, no, more, like, changes in jet streams, like, I'd say it's not probably no wonder. But I'll read the other ones first, but.
I'm sorry, wait, can we write on it?
I assume so. I mean, we can always, I wrote mine in pencil, so we can always.
I'm not, I have to, so I'm not.
It's just B,
That's where we pay
B,
for
C, D, or.
Okay.
Kind of like the bad kind of like, for example, that's what I use.
So, for the effects that it has,
Like, I don't have a highlighter, right?
but
No, it's fine, because I would.
I have marked.
the effects, it just says warmer during the winter months.
So for the grading, are we putting it on the sheet then?
Yeah.
Okay.
Yeah, and they have slightly different titles, so just go by what their title is.
What we're entering in the book. Or is that relevant?
That's just how bigger groups.
Oh, okay, alright.
No, it's all good. I wrote down some stuff over there because this won't let me use Word or anything to type up words,
Is
so.
weather changed? Question, who question we're gonna answer first, and then we're gonna explain.
What is the weather change?
What
What's the
is-
weather change?
What is the weather change? Is that word correct?
I think weather.
That's what it's just grammar.
What is the weather change? It's fine.
For example, I would count for 15, 25.
That's pretty impressive. I did not do that.
Yeah.
That's C.
Need a degree for that. Just kidding.
What else?
It's,
Increase snowfall.
yeah.
Increase rainfall, increase
Snowfall.
It's like right off of,
It's a weekly shot. I'm working great information for this.
This paper says in more phase and she'll call it El Nino, just the new results and subsequent. Go to this right now.
weather.
But like in a different way.
It's
I'm not. I was gonna say the folks. I feel like the folks gives away. I think this one is just a little bit more like concise.
We agree that it's
Yeah.
B, C,
Well, I mean, I
But I mean, like,
but it's way more.
Yeah, it's like, I was like, yeah, if you're grading a paper, especially that's like a scientific research paper, and you see folks that already gives like an informal input, and you're gonna like discredit the information.
I'm writing on,
You can.
you're writing on,
If
he's
you
writing.
want, you can go with this one.
These are writing on this.
I think it's just
Okay.
and this one incorporates it, like
No, it's
according
fine.
to
I
a
got
study, whatever, this one just kinda says another study.
Annie also quotes the question in her sentence. He or she or they. They, so inherent things are having in, so. There's not that, but like, that don't actually say like.
This is a specialization of more phase of events of
We don't wanna give
being
away
able to
what,
produce odds
that's
and above
exactly
what
that, you wanna make them keep reading
Why
slower.
is this when the window push
I think or sentences in each sentence.
and then like the warm water can be later.
So sorry.
It's hot, and I'm like, oh, sorry.
Yeah.
And it just like throws off.
No.
You gotta know what good sources are.
Oh hey, I typed up some specifics in case you can't read my writing on the board, but this is your turn in if you want the specifics of what you're written a little bit better here.
Okay.
Are y'all done?
And I was gonna say, I think the quality of sources here are a little bit better than here, because these are just like these are like Department of Natural Resources. Yeah, that's a good source, but
Format.
yeah. And this is like weather journals,
Like
like,
possibly references.
yeah.
Trust me, I've done a lot of in modern times and that's like, we are probably aware of that. And I definitely.
Yes, I was like, this is.
I'm already saying.
That one's it. I'm always like, okay. Sorry, I keep thinking of
No.
A, B, C.
Yeah, I'm gonna say like.
But you need more references.
It's not like they're technical references, it's just these are like
Exactly.
Journal of Hydrometeorology, that's a real journal, like.
I think we don't know all those.
It's
What do you think of this?
We're supposed to explain why.
Just kinda like
stuff
in
should be
between.
Well,
marked.
I
This one's bad.
Should we mark it up?
I think we should mark up one. I think we'll mark up one.
Yeah.
Okay, so we mark it up, and then.
Should we do it on,
Also turn.
should we do it on some piece of paper? So we could just be like, we can just get the title
We
and be
can,
like.
we can tap, like, we,
Yeah, we
there's,
can
if there's just, well, if we have, there's stamp one,
It's okay, I guess.
potentially.
We could just write on the, just write in the like margins of the paper, and like,
Yeah.
look, and then pointing to
Or
it, being
just like, yeah, cause
look
one,
at the bad from the year, they said.
or
folks.
put it at the bottom,
Yeah,
to have the most space.
you can also, I don't think you can do either.
Yeah, so, and we'll write on yours since we have.
Sure, I don't mind either.
Is that okay?
That's
I
fine.
just say the paper, paper, like, we don't have to be super, like, I'd say more detailed information with higher quality of sources. With the and then with the C paper, I'd say more informal tone, not as quality information, and less informal sources.
Okay, wait, hang on,
Okay.
sorry. Okay, I can look right the, or we each take turns writing one.
Yeah. So do
So
you
it's fair?
wanna,
I will do the B first.
I'll do the D paper.
Nice.
C paper.
Wait, you have, it's one of yours.
Which one is this, did you decide the C?
The one that's, it starts with folks.
Folks,
Or we can use mine.
Which one, yeah, it's like doing it.
wait,
We can make them up.
wait,
Yeah,
this
it's
one, that's now let's talk about is the C?
That's the D paper.
That's the D?
Yeah.
We didn't go with folks with this?
And.
That's
No,
so.
it's BCD. So that's C. This one is the D
Okay.
paper. And then the other one is the B paper.
This one with folks is The D paper?
C paper.
C paper?
This,
Okay.
now let's talk about, this is the D paper, that one.
Oh, okay.
Okay, so what is this is B paper?
High quality sources like,
Because,
or no, this is the C paper,
no, this is the,
folks.
oh,
This is the C paper.
dang it.
Yeah. I'd say like less quality source. The B paper is like highest quality sources.
You should, I'm saying you should provide, because I've used that since. It has the highest quality.
Yeah, like I
Yours really has the.
making sure this is the one I'm doing. Yes.
Oh no, I'm doing this
You're
one.
doing that
So you're
one?
doing the C paper.
And I'm doing this
That's
one.
the C paper.
Okay, just making sure.
They're good.
Good.
Each resource is cited correctly.
I guess so.
Okay, so we said officers so far have two tests that has the highest quality of sources. Cited correctly.
Most detailed information, like out of this paper,
Oh, I'm looking at most detailed.
like I can answer the question of this one, like you know, the El Nino linked to higher temperatures in December.
Yeah.
Very likely to change.
Most detailed information.
It's so weird. So yeah, we can just like combine all of these together on a separate piece of paper.
That's ability to
Stop this.
answer.
Stop.